Okay, so let's talk about making confidence bands. Turns out we can make prediction intervals and confidence intervals for a whole bunch of XH values at a time, um, and so you'll see how that goes here. Let me just get some things popped into R here real quick, and so I can get ready here. Now I'm going to go ahead and put these commands in. We'll see what this does. This first one here, I'm using the predict function again, like I did earlier, and this is the output for my linear model here that I've stored, and I'm making a confidence type interval with a confidence level of 95%. Okay, and you can see what'll happen if I do that. I get just what I got before, conf1. Okay. Except, whoa, look at this. It actually spits out 10 confidence intervals. See that? Pretty nice. 10 confidence intervals for these based on I think it's the X values that were actually in the data set. Okay. You'll notice that here you had a couple X values that were the same, and so they spit out exactly the same fits and lower and upper values. I can also do it for prediction intervals. So these will just give you, the default here is that it gives you the confidence and prediction intervals based on the X values that you actually already observed. Okay. Now, maybe though, what you want to do is make a whole bunch of them, not just on the explanatory values, variable values that you've seen. And then in fact, maybe you want to graph some bands. So here's how you can do this. First of all, I'm going to make a sequence of X values. 51 of them. I know that just happens to be a good number, I think, because I've played with this a little bit. I'm going to run X values between 0 and 12. And I'm going to get 51 of them. I'm getting a sequence of those values, 51 values between 0 and 12. I'm going to store them in my X values, ND for new data. Okay, so you can see exactly what that is. Type ND and you see them. They're moving up in by some amount, I guess 0.24 or so each between each pair of numbers. And now if I rerun that predict command with the confidence stipulation there, but using ND for my new data set, what it's going to do then is it'll actually make confidence intervals at each one of those X values, each one of those 51 X values. And then if I do the same thing, but using the prediction criteria there, I'll get 51 prediction values. You can see well, conf2, okay, there they are. Okay, these are the numbers in the left hand column here are the fits, which sit right in between the lower and upper values. So these are confidence intervals. Okay, and they sort of ride along the line there. And then similarly, I've got prediction intervals. Okay, so now I think what I'm going to do is let's make some plots. Okay, so I'm going to that next line of code gives me a plot like this. Don't be scared of this. I'm saying I'm plotting Y versus X. The data is I've got it stored in a data frame D. I guess I don't really need that. My Y limits. This is telling me that I'm telling R that I want the Y variable to go from 0 to 250 and the X variable to go from -1 to 14. Okay, 0 to 250, -1 to 14. You can change that if you like, and it's also useful to play with these and see how it changes your graph. if I expand the X range there from left to right, it's going to squish the data and make it look more vertical, because it's got to make room for all the extra space, right? See if you do that, see what it did there. So the setting these, we'll see this again from time to time when we make plots, but setting these limits in the horizontal and vertical direction, or other directions, if we go in and out of the page here, can be extremely, it can have a real huge effect on how the data present themselves. Okay, and it can play real tricks on the human eye. But I want to put it back like I found it. Okay, now I'm going to drop a regression line there, AB line, on using the output of my linear model there, and now I'm going to use this command called matlines. Okay, this is just a little graphing command. What it'll let me do is the X values it's going to take from that ND data frame, and then the Y values it's going to take from that confidence interval output, and it's going to plot two of them for each one. Okay, all the rest of this stuff has something to do with the way the markers look. Color is 4. It means it's I guess blue is associated with the number 4 here. I think this has something to do with the line weight, and I'm not sure what this means. And then this is the character that I'm assigning to it, C for confidence. So you can see what it's done. It's made confidence intervals for every one of these X values. Okay, so if I say, if X is here at about 7.5, I can be 95% confident that the actual mean response will fall somewhere in here. Okay, notice that so these are bands. These are confidence interval bands. Okay, and notice, of course, that they're closest together right in around the mean of the X values. Okay. You can see that also as a function of the confidence intervals themselves. When you look at the margin of error, you see how it decreases in X bar. And similarly, I can make prediction bands using that next line of code. It's there in the notes, and I'll label those with P's and change the color. You can see I've changed the color to color 3. I don't even know what that what color that is. I think it's green. So there we go. And like we said before, the prediction bands are going to be wider, okay, because confidence intervals get wider, or they get smaller as your sample size increases. So if your sample size decreases, they're going to tend to get wider. And remember, these prediction bands are exactly the same as confidence interval bands, except for when you have a sample size of size 1. Okay, so that's that. Now there's something else that I want to point out. We'll get to this, and I think it's the next section, but something you want to be very careful of here. I cannot simultaneously say that I'm 95% confident that the mean response based on this X value is here, and 95% confident that the mean response for a value based on an X value here is going to be between here and here. Okay, that's called simultaneous inference. We can't do this. These are only good for if I want to pick one position on this horizontal line here, one age, and then run up and grab the confidence interval. Okay. All right. Now let's move on to something else called the working hoteling procedure. It turns out, this is pretty awesome, I think, that you can make confidence bands for the entire regression line. Okay, so that's a natural question to ask, right? If I went through and took another sample, the sample would look different. Okay, the sample would look different, and therefore next time I might get a regression line running this away, or maybe even have a different slope, a positive slope or something like that. So maybe you would like to somehow indicate the region in the plane where you think it's pretty likely that the regression line is going to where the actual regression line for the population resides. Okay, well, you can do that with something called the working hoteling procedure here, and this is the way it's done. Okay, notice that it's actually exactly the same procedure as the confidence interval procedure for the mean response, except that you have a W here instead of that T number. Okay, and this W, I guess, is for working hoteling. I'm not sure. Is this guy? It's the square. W is the square root of 2 times an F random variable. Okay, so here's what I'm going to do. I'm going to start off and go ahead and compute that. Let R compute that W for me. Okay, it's the square root of all that stuff. By the way, this QF. I'm getting the 95th percentile for an F distribution with 2 numerator degrees of freedom and 8 denominator degrees of freedom. And then I'm going to create a new data frame here, call it WH bands, just because I think that's probably a good thing to do. And then I guess the next thing I'm going to do is like so, create these two objects, WHL, WHH. Look at what WHL is. It's actually so I'm, again, like I've been doing, I'm sort of doing this the long way. Okay, I'm taking WH bands. I'm starting with is the data frame that I got from the confidence interval estimate data frame for the mean response. Because remember, this working hoteling procedure, it's the same as that, except you replace the T number by a W number. So I'm getting the 2 confidence interval endpoints, and I'm summing them and dividing by 2. That's getting me the fits, right? It's getting me the fits on the line, and then I'm going to subtract and add some amount, right? What am I going to subtract and add? So the margin of error, right? What I have to do is I have to adjust for that. I'll take the margin of error that we started with, and somehow I got to divide through by that T number and multiply by the W number. Okay, so that's all I've done there. And so now what I'll do is I'll use the cbind command to add some columns, right? Cbind, that's column bind, just like rbind is row bind. Okay, I'm going to bind to the end. I'm going to concatenate sort of I'm going to start with this WH bands, and then just to the right of it, I'm going to put WHL and then WHH. Those are the lower and higher, I guess, is what I was thinking there. Working hoteling interval bounds. So you can see, if you type head of that data frame, it'll give you the very top of it. Okay, so you can see that's exactly what's going on here. We're getting, these are the working hoteling interval endpoints, and now I'm going to do the same kind of thing as I did before using that matlines command, but this time I want to indicate the working hoteling interval endpoints. And I'll use a star, let's say, and I'll use a different color. Okay, so the stars are going to indicate the working hoteling bands. Okay, and there they are in light blue. Okay, there they are in light blue. You can see that they're a little bit wider than the confidence intervals for mean response. Okay, so that's kind of nice. That is, we can be, I forget what the confidence level was in there that we were using, but we can be pretty confident, I guess, that the actual regression line would is somehow flying right in between those two light blue bands. Now, all of that's kind of hard, I think. So again, if you know some R commands, if you look this stuff up, you should be able to replicate it using actual R commands, and that's what I'm going to do here. Confidence intervals I'm going to set to be the output of this predict function, taking as argument the output from my linear model. I'm going to stipulate SE fits are true, so it's going to, you can see what that does. It's going to store the standard errors of the fits. Okay, so the again, as before, I'm gonna get this W number. Okay, I'm going to use this command here. I'm going to cbind. If I look at the CI fit, right, where the fits, okay, I've got the fits. I'm going to subtract W times CI SE fit, right? I'm getting my intervals here. You see that? Okay, and so you can see what band looks like. Those are getting me the bands there, and then I'm going to use this points command, and you can see what those are doing there. Actually, you know what? Before I do that, I think I need to replot my stuff. Right? Let's do that. Okay, and drop a regression line on there. Now let's use those points commands. Okay, and what that's going to do is whoops, looks like I've used an old I've attempted to use something called used cars, which doesn't exist. So let me try that again, but see if I can fix that here. Let's do maybe I can just do right, and then okay, that works. Okay, and then that was the same, right? There we go. That should work. Okay, and take a look at that. Yeah. Okay. So these should be the same. Okay, these should be the same as what we had before with the light blue stars. Also, by the way, you can add a legend if you like this. Okay, but the way I did that should be pretty self-explanatory. Okay, this CB for confidence band, for working hoteling confidence band. By the way, the way this points function works, I want to point out is it's going to sort it's going to sort of connect those points in there, but it's got to sort them first. And if our regression line had a positive slope, we want to take this decreasing out or set it to false. Okay, that's just something you might want to know.